There are several possible causes for magnetic field interference affecting computer monitors. Firstly, consider magnetic fields from nearby equipment. Check for any magnetic equipment in the vicinity, such as transformers, motors, or even MRI machines if the building houses medical facilities. Secondly, investigate whether the cubicles themselves contain magnetic materials. Metal filing cabinets or steel framing within the cubicles could be contributing to the issue. Thirdly, explore the possibility of magnetic field leakage from the computers themselves. Some computer components, particularly power supplies and hard drives, can generate magnetic fields. Examine the computers for weak shielding or electrical leakage. Fourthly, assess whether the HVAC system is a source of interference. Air conditioning or heating ducts can sometimes carry magnetic fields. Verify if the affected monitors are located near any ductwork. Fifthly, consider electrostatic discharge, also known as ESD. ESD can generate magnetic fields. Check for carpets or fabrics in the area that may be prone to building up static electricity. Sixthly, investigate the potential for interference from electrical wiring. Loose or faulty electrical wiring can create magnetic fields. Inspect the wiring in the immediate area of the affected monitors. Seventhly, a large electromechanical relay within the building could be the source of magnetic interference. Check electrical panels and the HVAC system for such relays. Eighthly, consider security systems. Some security systems utilize magnets or magnetic sensors. Check if any security equipment is located near the affected monitors. To effectively troubleshoot the problem, one of the first steps is to isolate the monitor. Move the affected monitor to a different location away from any potential sources of interference. This will help determine if the issue is specific to the original location. Secondly, check the power supply grounding for both the computer and the monitor. Ensure that both are properly grounded, as improper grounding can contribute to magnetic field issues. Thirdly, consider using a demagnetizing coil. A demagnetizing coil can help neutralize magnetic fields. Run the coil over the affected cubicle or desk drawers to see if it alleviates the problem. Fourthly, conduct a thorough inspection of the HVAC system. Verify that the HVAC ducting is not interfering with the monitors. Fifthly, re-establish contact with the cell phone company, providing them with more specific details about the issue. Inquire if they can use more advanced equipment to detect any potential radio frequency interference. Sixthly, if all other troubleshooting steps prove unsuccessful, consider installing magnetic shielding around the affected area. This can help block out external magnetic fields. When checking for magnetic fields from nearby equipment, pay close attention to large electrical devices that are known to generate significant electromagnetic fields. These could include large transformers used for building power distribution, industrial motors used in manufacturing or HVAC systems, or even specialized equipment like MRI machines if the building is connected to or near a medical facility. When investigating magnetic materials in the cubicles, thoroughly examine the construction of the cubicles themselves. Look for steel framing, metal panels, or any other ferrous materials that could become magnetized. Also, check the contents of desk drawers and filing cabinets for metallic objects that might be contributing to the problem. If you suspect magnetic field leakage from the computers, start by examining the power supplies. Power supplies often contain transformers and other components that can generate magnetic fields. Look for any signs of damage or wear that might indicate a weakening of the shielding. Additionally, check the hard drives, as their spinning platters and read/write heads can also produce magnetic fields. Ensure that all computer components are properly shielded and that there are no signs of electrical leakage. When assessing the HVAC system, pay attention to the proximity of ductwork to the affected monitors. Large metal ducts can act as conductors for electromagnetic fields, potentially radiating interference to nearby equipment. Also, check for any electrical components or wiring associated with the HVAC system that might be a source of magnetic fields. If you suspect electrostatic discharge, try to identify the sources of static electricity. Carpets, synthetic fabrics, and even dry air can contribute to static buildup. Consider using anti-static mats, sprays, or humidifiers to reduce the risk of ESD. When inspecting electrical wiring, look for loose connections, frayed insulation, or any other signs of damage. These conditions can create electromagnetic fields that can interfere with sensitive electronic equipment. Also, check for proper grounding of electrical circuits, as improper grounding can exacerbate electromagnetic interference. If you suspect a large electromechanical relay, try to identify its location and function. Relays can generate significant electromagnetic fields when they switch on and off. If possible, try to shield the relay or move it further away from the affected monitors. When considering security systems, check for devices like magnetic door sensors, access control systems, or surveillance cameras. These devices often use magnets or magnetic fields to operate, and they can potentially interfere with nearby electronic equipment. When isolating the monitor, be sure to move it far enough away from any potential sources of interference to get a clear reading. You may also want to try using a different monitor to see if the problem persists. When checking the power supply grounding, use a multimeter to verify that the ground connections are properly connected and that there is no voltage difference between the ground and neutral conductors. If you find any problems with the grounding, consult with a qualified electrician to correct them. When using a demagnetizing coil, follow the manufacturer's instructions carefully. Be sure to move the coil slowly and evenly over the affected area to avoid damaging the equipment. Also, be aware that demagnetizing coils can generate strong electromagnetic fields, so avoid using them near sensitive electronic equipment. When inspecting the HVAC system, check for any signs of damage or wear that might be causing it to generate excessive noise or vibration. These conditions can sometimes contribute to electromagnetic interference. When contacting the cell phone company, provide them with as much detail as possible about the problem. Include information about the location of the affected monitors, the types of interference you are experiencing, and any other relevant details. This will help them to better understand the problem and to provide more effective assistance. When considering magnetic shielding, be sure to choose a shielding material that is appropriate for the frequency range of the interference you are trying to block. Also, be aware that magnetic shielding can be expensive and may require professional installation. Additional tips to consider involve using shielded cables for all connections to the monitor and computer, as shielded cables can help reduce the amount of electromagnetic interference that is radiated from the cables. You should try reorienting the monitor and computer to see if changing their orientation reduces the interference, and consider using a line filter to filter out any noise on the power line that may be contributing to the problem. Be certain that all electrical equipment in the area is properly grounded and avoid running power cables and signal cables parallel to each other, as this can increase the amount of electromagnetic interference. You may consult with an electromagnetic compatibility, or also known as EMC, expert for assistance with troubleshooting and resolving the problem. Also, keep a detailed record of all troubleshooting steps you take, as this will help you to track your progress and to identify any patterns or trends. It can also be helpful to take photographs or videos of the affected monitors and the surrounding area, as this can help you to document the problem and to communicate it to others. If you are unable to resolve the problem yourself, you may need to contact a qualified technician for assistance. A technician will have the knowledge and equipment necessary to diagnose and repair the problem. Remember that troubleshooting electromagnetic interference can be a complex and time-consuming process. Be patient and persistent, and you will eventually be able to find the source of the problem and resolve it. Also, remember that safety is always the top priority. If you are not comfortable working with electrical equipment, be sure to contact a qualified electrician for assistance. Here's a more detailed breakdown of potential causes and troubleshooting steps. Firstly, deeply investigate the grounding system. Improper grounding is a very common culprit in electromagnetic interference issues. Ensure that all equipment, including the computers, monitors, and cubicles, are properly grounded to a common ground point. Use a multimeter to measure the ground resistance and verify that it is within acceptable limits, typically less than 5 ohms. Secondly, analyze the power quality. Fluctuations in voltage or current can generate electromagnetic interference. Use a power quality analyzer to monitor the voltage, current, and frequency of the power supply. Look for any abnormalities, such as voltage sags, surges, or harmonics. Install a power conditioner or uninterruptible power supply to stabilize the power supply and filter out noise. Thirdly, conduct a spectrum analysis. A spectrum analyzer can be used to identify the frequencies of the electromagnetic interference. This can help you to narrow down the source of the interference. Fourthly, perform near-field scanning. Near-field scanning involves using a probe to measure the electromagnetic fields in close proximity to the equipment. This can help you to pinpoint the exact location of the source of the interference. Fifthly, implement shielding techniques. Shielding involves enclosing the affected equipment in a conductive material to block electromagnetic fields. This can be an effective way to reduce electromagnetic interference, but it can also be expensive and may require professional installation. Sixthly, consider cable management. Proper cable management can help to reduce electromagnetic interference. Avoid running power cables and signal cables parallel to each other, and use shielded cables whenever possible. Also, be sure to properly terminate all cables to ensure a good ground connection. Seventhly, check for reflections. Reflections can occur when electromagnetic waves bounce off of conductive surfaces. This can create standing waves that can interfere with electronic equipment. To reduce reflections, use absorbing materials to dampen the electromagnetic waves. Eighthly, test for common mode currents. Common mode currents are currents that flow on the ground conductor. These currents can generate electromagnetic interference. Use a current clamp to measure the common mode currents and install a common mode choke to suppress them. In summary, addressing the monitor magnetic field interference requires a systematic approach that includes identifying potential sources of interference, conducting thorough testing, and implementing appropriate mitigation techniques. It's essential to prioritize safety when working with electrical equipment and to consult with qualified professionals when necessary to ensure a safe and effective resolution.